Hi, this is your TA Deepika. So we are going to start the live session in 5 minutes so that we can wait if anyone else joins. And in 5 minutes, we will go through the questions for today's tutorial. Good evening, everyone. I hope my slides are visible to you. Can any one of you please unmute yourself and let me know if it is visible and am I audible?
Yes, ma'am.
Thank you very much. So let us start today's class. And in between, if you face any difficulty in seeing the slides or having understanding the concepts, please let me know. So let's start today's tutorial. So, good evening, everyone. I welcome you all to the first tutorial of this course, Symmetry, Stereochemistry and Applications, conducted by NPTEL, whose course instructor is Professor Anshuman Roy Chaudhary from Aiza Mohali. And I'm your PMRF teaching assistant, and I'm doing PhD in chemistry at IIT Bombay. So, this course will run from January to April. You must have already gotten the notifications. And so, I hope you have gone through the lectures for the first week, which were available to you on this topic, symmetry, stereochemistry, and applications. And if I correctly remember, for the first week, the content was nomenclature of organic compounds. Okay, so we will just quickly go through the concepts which were covered by Professor Roy Chaudhary, and then we will try to solve some easy as well as some hard questions on the topic. Okay, so also I would like to tell you that you will also get the recording of this whole session on the YouTube channel Tutorials by Deepika. If you find any difficulty in searching for it, I can help you in the upcoming tutorials. So let us start for the questions. First of all, I hope you are aware of the priority list of different functional groups. So if we quickly look through all these functional groups, you have the highest priority assigned to the carboxylic acid group, followed by sulfonic acid, which is then followed by anhydride and ester, then acid chloride, amide, cyanide or nitrile, aldehyde, ketone, alcohol, thiol, amine, and epoxy, which is cyclic ester. Okay, so you can quickly take a screenshot if you want, or you will also get information about these on the lectures covered on the first week. So this is the priority list from upper to the lower side, and whenever there will be the presence of different functional groups in organic compound, we will take help of this priority list to assign the naming of the functional groups. Okay, so let us start with the first question of the day. Okay, so I have here given simple hydrocarbons. Okay, no functional groups are present. So let us solve the how to name these compounds. Okay, so let us try. As you know that whenever we have to name a hydrocarbon, we have to look for the longest parent carbon chain. Okay, so since this is a symmetric molecule, we will take any of these chains as the parent carbon chain. Okay, because they have the same number of carbon atoms. So let us say that we are considering this carbon chain. So here we will have 1, 2, 3, 4, 5. So 5 carbon atoms are present in the parent carbon chain. And if we consider this as the first carbon, then we are going to have 2 different ethyl substituents on the third carbon of this compound. So till now we know this information that our parent carbon chain will have 5 carbons, out of which the third carbon will have 2 ethyl substituents. Hence, if we have to name this compound, the name will be 3,3-diethyl pentane. Okay, and hence since 2 different substituents are present, the prefix di will come before naming the substituent. Hence, this compound will be called as 3,3-diethyl pentane. So I hope that was clear, and this was an easy question. Okay, let us move to the next hydrocarbon, which is also easy but a little complex than the first one that we have solved. Okay, let us look for the parent carbon chain in this particular example. So here you have different possibilities of having parent carbon chain. Okay, we can start from either here, or we can start from here, or we can start after starting from here, we can move till here, or we can move till here. Okay, in this direction also we can move. But like you have seen the rules of nomenclature in the lectures provided by Professor Roy Chaudhary, we have to choose that parent carbon chain where the substituents present will get the least number. Okay, like for example, if we start from here and we go till here, these substituents will get the number 3. Okay, but suppose we start here and move like this, we come back here, then these substituents will get a number of 1, 2, 3, 4. Okay, so definitely 3 will be preferred over 4. So hence, if we have to name this compound, we will have to move from here and we have to trace it till here, or we can trace it here also, since these two are identical. Okay, so you can go either in this direction or you can go in this direction. Okay, so hence the name of this compound will be 4-ethyl 3,3-dimethyl hexane. Since the parent carbon chain will have 1, 2, 3, 4, 5, 6 carbon atoms. Okay, hence it will be called hexane. And I hope you remember that ethyl is coming first because alphabetically E comes before M. Okay, so come first 4-ethyl 3,3-dimethyl hexane. I hope these easy examples were clear to you. Okay, so after one by one with the questions, we will move towards a more difficulty level questions. Okay, so anywhere you get any doubt, you are please feel free to ask about the question, or we can later interact in the upcoming tutorials also. So okay, so I hope these examples were clear to you. Let us move to the next examples. Okay, so here let us look at this question first. This is also another hydrocarbon, but before this we have solved the names of two acyclic hydrocarbons. This time we have a cycle. Okay, the parent you can recognize, it is a cyclohexyl ring. Okay, so the cyclohexyl ring is having 3 different substituents. So like I said in the previous example, you have to consider that direction of the ring where you will have the least number assigned to the substituents. Okay, so here if we assign 1 to this carbon atom, we will have 2 1, like 1 for 2 substituents and 2 for 1 substituent. Okay, so it will be 1 1 and 2, the sum will be 4. Okay, and whereas suppose I decide to start from a random carbon, suppose I am going to start from the 4th carbon, then if I have to move clockwise, my substituents will get numbers 1, 2, 3, 3 and 4. So that does not make sense. Okay, the sum will be way more than 4. So that is why we will move in this direction only. This carbon we are going to assign as 1, and this carbon we are going to assign as 2. Hence the name will be 1-ethyl 1,2-dimethyl hexane. Again, the ethyl is coming before methyl because alphabetically E comes before M. Okay, I hope this question was also easy to you. And now, after the three examples of hydrocarbon, we are going to introduce functional groups. Okay, so let us start with this easy hydrocarbon having a functional group which is an alkene. So while doing numbering in alkene and alkyne, minimum number should be given to the multiple bond. That means the multiple bond will always get a higher priority than saturated hydrocarbon. Okay, hence if we have to choose the parent carbon chain here, we must start it from the multiple bond. It will start here 1, 2, 3, 4, 5, 6, 7. So hence the carbon chain will have 7 number of carbons in the parent chain. And let us look at the name. It will be named as 4-ethyl hept 1-ene. This must be very easy to you by now because the ethyl chain is present on the 4th carbon of the parent chain. So with this, let us move to the further questions. Okay. So here we are going to talk about more number of functional groups. Okay. Which of the following compounds have main functional group? Alcohol. So all these 5 compounds which I have listed here, all of these are having alcohol functional group here. Okay. As you can see, in this alpha beta unsaturated ketone, we are going to have a hydroxy group present. Here also in this carboxylic acid, we are going to have a hydroxylic group. Okay. And in this amine as well, we have a hydroxyl group. And in this compound where we have a thiol, we have an amine. Here also we have a hydroxyl group present. And in this aldehyde, we have a hydroxyl group present which is in the form of enol form. Okay. But it also have a hydroxylic group present. Hence, out of these 5 compounds, you have to choose those compounds where we are going to get the hydroxyl group, the alcoholic functionality as the most priority group, highest priority group. Okay. For that, you have to go back to the priority list which we talked about in the beginning of the lecture. Okay. As I hope you remember this priority list, we have all the functionalities present here which are present in the structures given in the question. Okay. So if we go back through this priority list, we can see that amine and thiol and epoxy, these 3 are the functional groups which are having lower priority than the hydroxy group. Okay. Rest which were present in the question, the aldehyde and the carboxylic acid and these 2 will be more priority than the hydroxyl group. Okay. Hence, we will go back to the question. Now you know that hydroxyl group is having lower priority than aldehyde and ketone and carboxylic acid. Okay. Hence, out of these 5 compounds, only 2 will have the main functional group as alcohol, which will have the thiol and amine group. Okay. So in 3, where we have the amine group, this will be an alcohol as the main functional group. And here as well, we have only amine and thiol, which are having lower priority. So this alcohol will also possess the hydroxyl group as the main functionality. So hence the idea of priority will come to the picture while solving this question. I hope this was clear to you. Okay. Okay. So now another easy nomenclature question I have for you. So I have listed 6 compounds here, okay? Out of these, all are having an aromatic ring, okay? These are substituted benzenes, you can roughly say. So out of these substituted aromatic rings, I will solve only one question here, and the other 5 you can try at home, okay? You can take it as a take home assignment and you can solve by yourself. These are very easy. It is just an aromatic ring which will be having methyl, nitro, halo, chloro, and hydroxy, carboxylic acid. All these substituents present on the main ring, okay? So if we look at the first example, this first compound will be called as 1-methyl 2,4,6 trinitrobenzene, okay? Or if you want to call it with the help of common nomenclature, as we know that a benzene ring having a methyl substituent on it is commonly called toluene, okay? So you can use that common name also in naming this first compound. So hence it will become 2,4,6 trinitrotoluene, okay? So hence the numbers, if we name it as 1-methyl 2,4,6 trinitrobenzene, the number will be 1, 2, 4, 6. Okay. Hence, you can try to name all these 5 other compounds also. Now, we will solve another question which is having a cyclopentadiene ring. Okay. And this ring is having 2 halogen substituents, bromo and chloro. Okay, so let us try to solve this question. So the parent carbon chain will be a cyclopentadiene. Okay, so this 5-membered ring will have 2 substituents. Let us look at how to number the positions of these substituents. Okay, also as we have bromo and chloro substituents, we will also have to look for the alphabetical order of the first letter of the substituents. Okay, for example, the bromo will come before the chloro while naming the compound. Hence, this cyclopentadiene molecule will be named as 1-bromo, then 1, 2, 3, 4. Always move in the clockwise direction. Okay, 1, 2, 3, 4. So the name will be 1-bromo 4-chloro cyclopenta 1,3-diene. Okay, as we have already studied in one of our previous examples, that you have to give the priority to the multiple bond. Okay, so hence we will give 1 here and the second bond will start at the 3rd position. Hence the name will be 1-bromo 4-chloro cyclopenta 1,3-diene. I hope this was clear to you. And after this cyclic compound nomenclature, we will move to a complex hydrocarbon with no functional group. Okay, we have already solved various questions of this type. You may get confused with the positions which you have to assign to the to the substituents and also the parent carbon chain. Okay, so if we talk about this particular example, we will move from here till here. Okay, because these 2 branches have the same number of carbons. Okay, 1, 2, 3, 1, 2, 3. But we will choose only that branch where we have a substituent. Okay, out of these 2 branches, we have substituent on this below one. Okay, so hence we are going to choose this direction as our parent carbon chain. So now if we move from here to this end, we will say 1, 2, 3, 4, 5, 6, 7, 8. Okay. Hence, the parent carbon chain will be octane. Now, the nomenclature will include the positions of the substituents in such a way that the substituents will get the lowest numbers. Okay. Hence, the direction will start from here, and the first substituent, which is methyl, will get the number 3. Okay. So likewise, you can try to name the complete compound with the help of the questions we have already solved, and the name will be 3-methyl, 5,1-methyl ethyl, 4-propyl octane. Okay. So this propyl substituent is getting the fourth number because we are starting from here 1, 2, 3, 4, and in the fifth position we have a isopropyl group. You can either name it as isopropyl group, or you can use the IUPAC name for this group, which is 1-methyl ethyl. Okay, this chain has 2 carbons and having a methyl substituent at the carbon number 1. Okay, hence the name will be 3-methyl, 5-methyl ethyl. So 5 is coming first because the methyl M is present, which is alphabetically coming before P. Okay, hence the 5 number is coming first. 3-methyl, 5,1-methyl ethyl, 4-propyl octane. Okay, starting from here, the parent chain will be octane. I hope this name was clear to you. Okay, this was an example of a complex hydrocarbon molecule. Okay, so with this, let us move to some more complex examples. Now we have another hydrocarbon with 2 rings. Okay, one is 6-membered and the other is 3-membered. So whenever we have examples, such examples where we have more than one number of rings, we are going to choose the ring which is having more number of carbons as the parent carbon chain. Okay, and the smaller ring will be chosen as a substituent. So while naming this particular molecule, we will locate this substituent, the cyclopropyl substituent, at the first carbon chain. Okay, we will consider this carbon as the number 1 carbon. Hence, this ring will be 1, and in the bracket we will put the nomenclature of this substituent. Okay, so if we try to solve only the name of this substituents, this is 1-methyl cyclopropyl. Okay, if we look at this, okay, so if we look at this individual substituent present here, this will get the name of 1-methyl cyclopropyl. Okay, hence this substituent name will as a whole come in the bracket, and since we have already talked that this carbon will get position number 1, it will be 1 in bracket 1 methyl cyclopropyl cyclohexane. Okay, this cyclohexane ring will be having the parent carbon chain designation. I hope this name was clear to you all. Then let us move to the next question. So here, this is a simple example. You have a carboxylic acid functionality along with a cyclic ring which is having two carbon-carbon double bonds present inside the ring. Okay. So always remember that whenever we have multiple bonds versus functional group, we will always assign the higher priority to the functional group here. Okay. Hence, the parent carbon chain, the main compound, the main functional group in this compound will be carboxylic acid. Okay. And this whole unsaturated hydrocarbon group will be considered as a substituent on the carboxylic acid compound. Okay, so let us solve it one by one. So, as I have mentioned, this carbon atom will get priority number 1 and this carbon atom will get priority number 2. And the parent carbon chain will have 2 carbon atoms where we have this particular substituent on the carbon number 2. So like we solved naming of this compound, here also we will solve the name of the substituent first. Okay. So the substituent present in the carbon number 2 will be named as cyclohexa 1,3-diene. Okay. This cyclohexane ring is having 2 double bonds. Hence it will be cyclohexa 1,3-diene. And since it is present as a substituent, it will be called as cyclohexa 1,3-dienide. Now, this overall name of the substituent will come in the bracket and we will call it 2-cyclohexa 1,3-dienide ethanoic acid. Why ethanoic acid? Because the carboxylic acid is having 2 number of carbons in the parent chain. Okay, hence it will be 2-cyclohexa 1,3-dienide ethanoic acid. I hope the name was clear to you. Now we will solve some other such similar examples. Okay, this is a similar example where we have a multiple bond versus an aldehyde. Okay, so like I said, the functional group will get the higher priority. Hence, we will assign this functional group containing carbon as 1. Okay, and hence the substituent will be present at the carbon number 3. So, while naming the compound, we will have to name the substituent first, which is present in the carbon number 3. And if we solve the name, this substituent will be called as cyclopro-2-enyl, because the carbon which is attached to the main carbon chain, the parent carbon chain, that will be assigned number 1. Okay. And if we number this carbon as 1, these two will be 2 and 3. And hence the alkene, the carbon-carbon double bond, will be present in the carbon number 2 of the substituent. Okay. Hence the name which will come under the bracket will be cycloprop-2-enyl. Okay, so after naming this individual substituent, it must be very easy for you. So there is a correction, there will be a correction here. This is aldehyde, okay? Hence, it will not be butanoic acid, rather it will be butanol. Okay, the aldehydes always will get the suffix al to the name of the compound, okay? Hence, this compound will be 3-cycloprop-2-enyl butanol. I hope this name was clear to you. Similarly, in the next example, we have again a double bond, carbon-carbon double bond, along with a carboxylic acid directly attached to the double bond, okay? Again, we are going to give higher priority to the functional group, which is here the carboxylic acid group, okay? So, if we start numbering the parent carbon chain from here, it will be 1, 2, 3, 4. Okay. Hence, the parent carbon will be butene. Okay. 1, 2, 3, 4. It will be butene. Now, we are going to place the substituents along with their positions. Okay. So, if we are starting from the carboxylic acid functional group, 1, 2, 3. So, we have two types of substituents. The primary one will be methyl. Okay. So, it will be 2-methyl but 2-in. The double bond is present in the second position. It will be 2-methyl but 2-in oic acid. Oic acid because the parent compound is a carboxylic acid. Okay. So this is how you have to solve the name of such organic compounds which are having multiple bonds as well as a functional group. You have to name them step by step. First, identify what is the functional group because that is going to be the parent organic compound name. For example, we are using oic acid for here for a carboxylic acid and L for an aldehyde. So once you recognize the main functional group, after that you have to place the substituents in alphabetical order one by one using the least number that can be assigned to it. Okay. So I hope these names were also clear to you. After this, we are going to move to some examples which will be having some multiple functional groups. Okay. So here I have listed down a few carboxylic acids examples. So whenever you have a compound which is having two carboxylic acid groups, you can take a screenshot of this page if you want. So if multiple number of carboxylic acid groups are present in your organic compound, then you can remember the common names of these carboxylic acids as Ohm's gaps. Okay, OMS GAPS. Ohm's gaps. What Ohm's gap stands for? Oxalic acid, malonic acid, succinic acid, glutaric acid, adipic acid, pimelic acid and subbaric acid.
So this Ohm's gaps will help you in remembering the common names of dicarboxylic acids. So for oxalic acid, there will be zero number of carbon atoms between two carboxylic acid functional groups. Okay, and similarly for malonic acid, there will be one carbon atom, and for succinic acid, there will be two carbon atoms between the dicarboxylic groups. So you can use this abbreviation Ohm's gaps to remember the names of these dicarboxylic acid groups. So after this, now let us move to the further examples of this tutorial. So in the first compound, if we look at the main functional group present here, it will be an anhydride. Okay, what is anhydride? Anhydride are those organic compounds which formed by the dehydration of two carboxylic acids. So if we dehydrate two carboxylic acids, we will have a loss of water molecule as a whole. So hydroxyl OH group from one carboxylic acid will leave, and one proton from the other carboxylic acid will leave, and hence we will get an anhydride as the final compound. Now in this compound, we will look at the two sides of this anhydride. Okay, so on one side we have a methyl substituent in the second position, and on the other side we have a methylidene substituent, that is a carbon-carbon double bond on the second position of the other side. Okay, hence if we have to name it, we will go from the side where we have a substituent. Okay, so it will be 1 2 2-methyl propanoic, and in this side we have alkene, so it will be prop 2 in. I hope this is clear. On one side we have a methyl at the second position, hence it will be 2-methyl, and on the other side we have alkene at the second position, so it will be prop 2 in. Now if we put both the fragments together, the name will be 2-methyl propanoic prop 2 enoic anhydride. I hope the name was clear. Okay. Then in the next question, we have another anhydride in which we have the same number of carbon atoms, but the substituents are different. Okay. So here we will again follow the alphabetical order of bromo versus chloro. Hence the bromo side will come first. Okay. So the overall name, like let us solve it as fragment by fragment. Okay, for this fragment we have a bromo substituent in the second position, hence it will be a 2-bromo ethanoic, because the parent chain is having two carbon atoms. It will be 2-bromo ethanoic, and on the other side again we have two carbons on the parent chain, so it will again be 2-chloroethanoic. And now if we put both the fragments together, it will be 2-bromoethanoic 2-chloroethanoic anhydride. Okay, I hope this is clear. After this, now we have an ester. So this is the ester functional group present in the molecule. Okay. Here the functional group will be assigned the highest priority. Okay. The chain will start from here. Hence, if we count, it will be 1, 2, 3, 4, 5. Okay. And on the other side of the ester, we have a cyclopropyl substituent. Hence, the substituent side will come first and then it will be followed by the parent hydrocarbon chain. Hence, this carbon will be named as cyclopropyl pentanoate. Okay. The side which is attached to the carbonyl group will be called as the the main parent chain of this compound, and hence it will be called cyclopropyl pentanoate. A similar example has been listed here. In this ester, we have the main chain starting from here. Since this chain is having the carbonyl group, so it will be 1, 2, 3, 4 butanoate. Okay, the main compound will be a chloro-substituted butanoate. And the first part of the name will consist of this part of the ester, which is not directly attached to the carbonyl functional group. Okay, and this part is having 2 carbon atoms and is having 2 substituents, 1 methyl and 2 bromo. Okay, and also we have to mention the presence of the ene functionality. Hence, the name will be 1 bromo, 2 bromo, 1 methyl, eth, 1 enyl, this will be enyl. Okay, this will be carbon number 1. So 1 methyl, 2 bromo, 1 methyl. Since B will be given the higher priority according to the alphabetical order, 2 bromo, 1 methyl, eth, 1 enyl. Now we'll go to this side, 2 chlorobutanoate. This parent chain will be a butanoate. So it will be 2 bromo, 1 methyl, eth, 1 enyl, 2 chlorobutanoate. I hope this is clear to you. Then we will move to solve some other functionalities which are acid chlorides and amides. Okay, let us move to the acid chloride first. So this acid chloride is having the parent carbon chain as a 5-membered linear chain. Okay, 1, 2. Always assign the first number to the functional group. Hence it will be 1, 2, 3, 4, 5. Okay, and if you look at it, the third position is having a substituent. What substituent? It is again a cyclopropyl substituent. Okay, hence this compound will be named as 3-cyclopropyl pentane 1 oil chloride. Whenever you have an acid chloride as the main functional group of your compound, this oil chloride will come as a suffix to it. Okay. Okay. So after that, let us move to the amide compound. So this amide, whenever we have an amide, while naming, always assign the first number to the carbonyl group present in the compound. Okay. So this carbon atom will get the first number, followed by 1, 2, 3. Okay. Hence the parent carbon chain will have 3 carbon atoms and it will be called as prop. Okay, the prop prefix will come. Now, while naming amides, you also have to mention the substituents present on the nitrogen atom. Okay, hence, along with this bromo substituent, you have to mention the N dimethyl also in the name. Okay, hence, the name will be 2-bromo N dimethyl propanamide. Propanamide because the parent carbon chain is having 3 carbon atoms, hence it will be propane. Okay, so I hope the names of these acid chlorides and the amide is clear to you. Now let us move to the further questions. So now we are going to solve a few questions from the nitrile functional group. Okay, in the first compound, if you look at, this is having 2 multiple bonds, alkyne, and 1 nitrile. Okay, so out of these 3 functionalities, we will assign the nitrile the highest priority. Okay, hence, if we start from this carbon atom of the nitrile, the parent carbon chain will have 5 carbons. Okay, 1, 2, 3, 4, 5. And while naming the compound, we must mention the positions of the multiple bonds. So the in and wine will have to be mentioned. So it will be a pent 4 in comes first because of alphabetical order again. 4 in, 2 wine, 1 nitrile. Okay. Hence, your compound will be named as pent 4 in, 2 wine, 1 nitrile. Let us look at the second example of the nitrile. Okay. Here also we will assign the nitrile as the first priority, which will have a parent carbon chain as well as a ethinyl substituent. So the parent carbon chain, we are going to choose the bromo one by moving from here to here. Okay, we will choose the bromo one because of the higher molecular weight of the bromo over chloro. Okay, hence the name will get 3-bromo, and in the second position we have this chloro substituted alkylidene as the substituent. Okay, so this particular part will come under the bracket, and if you individually name this functional group, it will be 1-chloroethinyl. Okay, hence the overall name will be 3-bromo 2 1-chloroethinyl but 3 in nitrile. Okay, but 3 in because the parent carbon chain is having 4 carbon atoms, and the double bond will be starting from the third position of the parent carbon chain. Hence, the name will be 3-bromo 2,1-chloroethinyl but 3-N-nitrile. So, after this, let us now go to carbonyl compounds. Okay, so I have mentioned one cyclopentanone molecule here, which is having 2 double bonds inside the ring. Okay, always assign higher priority to the functional group here as well. So we will start from the carbon atom, which is the carbonyl group. Okay, so if we consider this as the as the first carbon atom, the double bonds will be present at 2 and 4th position. Okay, this will be the second position and this will be the 4th position, and the name will be cyclopenta 2,4-dienone. And you can mention the position of the carbonyl compound as well. Hence, the name will be cyclopenta 2,4-diene-1-one. Okay. So, another example of diketone I have mentioned here. Here, you have a double bond present. Okay. So, while starting the parent carbon chain, start in such a way that the double bond position will get the least number. So if we start from here, it will be 1, 2, 3. And if we start from here, it will be 1, 2, 3, 4. So third position will be preferred over the fourth position, and the name will be hept 3-in-2,6-dione. The position of the ketones are also mentioned, which will be at the second and sixth position. Okay, and the parent carbon chain will be having 7 number of carbon atoms. Okay, I hope this is clear to you all. Now let us move to some more complex examples. Okay, so in this example, if you look at, this is a amide, okay, which is also having an ester functional group along with 2 double bonds, and it also has a bromo substituent. So you must assign the amide functionality as the first carbon number of the parent carbon chain. Okay, so we will move from here and we will go till here. Okay, 1, 2, 3, 4, 5, 6, 7. So the parent carbon chain will have 7 number of carbon atoms. So after recognizing the parent carbon chain, we will now place the substituents one by one, and also we will place the double bonds one by one at the end by mentioning the least possible numbers. Hence, the bromo substituent will come first according to the alphabetical order, and it will be 5-bromo, 3-methoxy, 2-methyl, hepta, 3,5-dienamide. Okay, like I said, you have to mention the position of the double bonds in such a way that they move along the parent carbon chain and also they get the least number of position assigned. So it will be 5-bromo, 3-methoxy, 2-methyl, hepta, 3,5-dienamide. So after this amide, let us move now to some more examples, which will be now having multiple functional groups present. Okay, so in the first compound, if you see, it has two functional groups present. One is carboxylic acid and the other is a nitrile. So if we go back and try to remind ourselves about the priority list, the carboxylic acid group will always have the highest priority. Hence, we will choose this functional group, carboxylic acid functional group, as the starting point of our parent carbon chain, whereas we will choose the nitrile group as the substituent, because the parent carbon chain will extend till here, as it is going to have 7 number of carbon atoms. We can't move it till the nitrogen atom, otherwise the parent carbon chain will have 6 carbon atoms. Okay, so we have now recognized our parent carbon chain starting from here: 1, 2, 3, 4, 5, 6, 7. Okay, so the nomenclature will be done as 3 chloro, 5 cyano, 4 oxo heptanoic acid. We are assigning oxo to the carbonyl group because carboxylic acid will again have higher priority than the keto functionality. Okay, so 1, 2, 3. 3 chloro, 4, 5. 5 cyano, 4 oxo heptanoic acid. So cyano is placed before oxo because C will be come first in the alphabetical order. So I hope this group containing compounds naming was clear to you. Then we will move to the next example, which is again having 3 different functional groups. One is carboxylic acid, second is acid chloride, and the other is amine. Okay, which is a secondary amine. So again, the carboxylic acid group will get the highest priority, and hence we will extend our parent carbon chain from here to here, and will place the amine and the acid chloride groups as the substituents. Okay, so starting from this carbon atom as number 1, this compound will be called as 3-chloroformyl. Whenever you have acid chloride as a substituent, we will use formyl as a suffix, and hence it will be 3-chloroformyl, 2-methyl, 4-N-methylamino pentanoic acid. Okay, first you have to recognize the parent carbon chain, and then you have to place the substituents irrespective of it being a hydrocarbon chain or a functional group. We are going to place them in alphabetical order. So C will come first, and then methyl, and then N-methylamino will come at the last. Okay, I hope the name of this multifunctional carboxylic acid was clear to you. So let us move to some more such examples where we will have multiple functional groups. In the first example, if you look at, it is having an alcohol, a keto, and an amine functionality. Okay, as we know that out of these 3 functional groups, the carbonyl group will again always have a higher priority in comparison to hydroxyl group or amino group. Okay, hence the parent carbon chain will consist of this keto group, and we will start the parent carbon chain from here. It will be 1, 2, 3, 4, 5. It will be a pentanone. Okay, and after recognizing the carbon chain as pentanone, we will now place the numbers along with the substituents. So amino group will come first, which will be followed by hydroxy group. Okay, so the name will be 3 amino, 1 hydroxy, pent 3 in, 2 on. Okay, amino will come first, hydroxy group will come second, and it will be followed by the double bond and also the ketone. Then in the next example, we have 2 keto groups along with a carbon-carbon double bond present in the ring. So the parent carbon chain will be a cyclohexene dione. Okay, but we must know from where to start the numbering, because the substituents must get the least numbers assigned. Okay, so you can identify the different possibilities of numbering, but make sure you are moving in a clockwise direction. And hence, if we start from this ketone, the substituents will get 2 and 5 numbers. Okay, but if we start from some other random positions, the substituents will be assigned higher numbers, which will give you a higher summation. Okay, hence you will start the naming from here, and hence it will get a 5 bromo, 2 chloro, cyclohex, 2 in, 1 4 dione. Okay, you have to mention the position of the carbon-carbon double bond as well. So after this diketone, now we will move to the nomenclature of some complex hydrocarbons, which are bicyclic compounds and spirocyclic compounds. Okay, so let us start with the bicyclic compounds. So the first compound is a bicyclic compound where 2 cyclic rings are fused, one of which is 1, 2, 3, 4, 5, 6, 7, 7-membered ring, and the other is a 3-membered ring. So this name, as you know already, the bicyclic compounds naming will always start from the prefix bicyclo, which will be followed by a bracket which will contain the number of carbon atoms present in both the sides of the junction. Okay, and while putting the numbers inside the bracket, always remember you have to go from higher to lower number of atoms. Okay, hence the first compound, if we look at the name, it will be a bicyclo 5 1 0 will be placed because there is no carbon atom in the fused part. Okay, hence it will be bicyclo 5 1 0 octane. Octane because the total number of carbon atoms in this bicyclic compound is 8. Okay, so similarly, let us move to the second example. Here also, if we look at it, in the junction we have 3 different directions where we have atoms. Okay, if we consider this part first, we have 1 carbon atom towards the left, 1 carbon atom towards the right, and 1 carbon atom above. And if we count the total number of carbon atoms, it is 1, 2, 3, 4, 5. Okay. Hence, the name will be bicyclo 1, 1, 1 pentane. Why pentane? Because the number of carbon atoms, total number of carbon atoms present in the compound is 5. I hope it is clear. Okay. So, in the next example, we have two substituents present in the bicyclic rings. Okay. So, while naming the substituents in the ring, we will follow again the alphabetical orders. Okay. So, the C will come first, which will be followed by the E of the ethyl substituent. And the numbering will always start from the junction carbon atom, which will then move in a clockwise direction. Okay, so hence it will be 1, 1, 2, 3, 4, 5, 6, and 7. We out of these two carbon atoms, we are going to place first carbon atom as here present here, because otherwise, if we number this carbon atom, the above one carbon atom, as 1, the ethyl substituent will get a very high number, which is not allowed. Okay. Hence, we will choose this carbon atom as the first carbon, and we will assign second position to the ethyl substituent. And the overall name of this compound will be 7-chloro 2-ethyl bicyclo 2,2,1 heptane. Okay, I hope the bracket 2,2,1 numbers are clear to you, because we have two carbon atoms on both the sides of the bicyclic ring, followed by one ring at the junction position. Hence, it will be 2,2,1. And in the last example, if we see, again we don't have any carbon atom at the above the junction, so the bracket numbers will end with a 0 here, and before that we will have to place 3 and 2. Okay, and we will also have to mention the substituents present, which are bromo and methyl. So if we have to name this compound, the naming will be starting from 1, 2, 3 bromo, 4, 5, 6 methyl, bicyclo, 3, 2, 0 heptane. Heptane because the number of total carbon atoms in the bicyclic ring is 7. Okay, I hope the nomenclature of these bicyclic compounds are clear to you. So at the end of this tutorial, we are going to solve these 3 examples of the spirocyclic compounds. So while naming the spirocyclic compounds, you must remember that the names will start with a prefix spiro, which will be followed by a bracket, in which we are going to again place the numbers present on both the sides of the tertiary carbon atom of the spirocyclic ring, but the numbers will be placed in an increasing order. Okay, hence the least number will come first, followed by the higher number. So, and in the first example, if we see, it has 8 number of carbon atoms in total. So it will be called an octane. Okay, so it will be a spiro 2,5 octane. The numbers will be in increasing order. Always remember, in spiro the numbers are in increasing order, and in bicyclo the numbers are in decreasing order. And similarly, in the next example, we have 2 rings which are in a spirocycle fashion, and the Total number of carbon atoms is 8 here again. So the parent carbon chain will be an octane, and the substituents will be named in such a way that they get the least numbers possible. So if we start the naming from here, it will be 1, 2, 3, 4, 5, 6, 7, 8. Okay. So the naming will be 5 bromo, 1 ethyl, spiro, 2, 5 octane. Okay. 2, 5 is coming because the smaller ring is having 2 members and the bigger ring is having 5 members. So it will be spiro 2, 5 octane. And in the last example of the spirocyclic compound, we again have a spirocyclic compound where we have 8 number of carbon atoms in total. So it will be an octane, and the substituent in the smaller ring will get the first priority, hence it will be 1 ethyl. Okay, and if we look at the second ring, it is having a double bond as well as a substituent. Okay, so it will be named as 1, 2, 3, 1 ethyl, 4 methyl, and while naming the octane, you have to mention it is oct 5-ene. Okay, hence the name will be 1 ethyl, 4 methyl, spiro, 2, 5, oct 5-ene. Okay, 2, 5 because one ring is having 2 carbon atoms, and 5 because the other ring is having 5 carbon atoms, and hence it will be spiro 2, 5 oct 5-ene. So with this we have solved various nomenclature problems on the organic compounds, which was the topic for the week 1 lectures. I hope it was clear to you. Let us quickly go through all the questions as a revision, and you can also take screenshots if you want. And like I mentioned, the recording of this tutorial will be available in the YouTube channel Tutorials by Deepika. And if you find any query or any doubt, you can reach to me. Okay, I will mention my email ID in the next tutorial on my slide. In this one, I forgot to mention, so that you can reach via email as well. Okay, so let us have a quick revision of what we solved today. So we started our lecture with this priority list of functional groups, and after that we started the nomenclature problems with these hydrocarbon atoms, and then we included multiple bonds in the nomenclature. Also, we talked about this particular examples where we got to know that amino and thiol groups are having lesser priority than alcoholic functional group, and then we tried to solve the naming of this aromatic compound which are substituted, and then we solved some more complex problems having multiple bonds and also multiple substituents on the parent carbon ring, and then we solved these questions having two cycles in the compound, and also we then solved questions from the functional group present compounds, and we went through aldehydes, carboxylic acids, and anhydride, acid chlorides, and ester functional groups, as well as some more acid chlorides, amides, nitriles, and diketones. Okay, and after that we solved some examples where we have three different functional groups present, and we took the help of the priority list while naming these organic compounds, which was followed by some more examples of compounds having multiple functional groups. And lastly, we solved questions from the bicyclic and spirocyclic compounds. So I hope it was clear to you. In the next lecture, we will solve some more examples on the topic Symmetry, Stereochemistry and Applications, and the topic covered will be the lectures of the week 2 classes provided by Professor Anshuman Roy Chaudhary sir. Okay, so thank you very much for joining. We will meet on next Friday at the same time for the second tutorial.
Okay, ma'am. Thank you.
Thank you very much.